So let's talk about the histological staining pattern here, and then we'll get into the structure a little bit closer. So basically we have different staining bands of this muscle, and we call them bands. This is how the muscle appears under the microscope. And a lot of what we're going to talk about with regard to the sliding of these proteins, is not, how do I say, has never been visualized. This is highly just a theory, okay? And this is why we call it the sliding filament model, because no one has ever actually visualized this happening, simply because when a muscle is contracting, it's in a living human being, right? We cannot look at a contracting muscle underneath the microscope. So the theory of how muscle contracts is just that, a theory, okay? A very reliable theory. So let's talk about the staining patterns. Again, this is how we see muscle under the microscope. We can see these differences in the thickness of the protein and how many proteins are overlapping in that region. And this is what gives us these unique staining areas that we call bands or lines on the muscle. Okay, so I really want you to understand that this is more of a histological appreciation, something that we see under the microscope. Now, the A bands that are stained, which is this region, is basically the area of overlap between thin and thick filaments. So it's slightly gray because we have overlap of two proteins. It's going to appear more densely staining than, say, this area that has just one protein or this area that has just one protein. So it's really important to understand that that overlap gives the A band a slightly shaded or a slightly grayed appearance, okay? And this is where we have overlap of thick and thin filaments, or actin and myosin. The H zone is the area where we don't have any overlap, okay? We just have thick filaments or myosin. The H zone, okay? And as you can see, it's a bit lighter staining or paler staining because there's no overlap. It's just myosin, it's just the thick filament in the middle. The M line is the area that links the thick filaments. So it's a bit darker again here because there's a connection between each of the myosin filaments here, right? And then the I band is another light staining region, much lighter, much paler. Why do you think this is so much lighter than, say, the myosin area? If you look at the structure of actin and myosin, the thin filament and the thick filament. So actin is much thinner, and we can see this here, right? This blue structure is actin, whereas the red structure is myosin, and actin is much thinner than myosin, and so it's gonna leave a much paler staining pattern histologically, okay? And that forms the I band. The Z line is the area that links the I band, that links all of these thin filaments, these actin filaments together. And so it's a little bit darker here in the middle. And so the Z line is the area that demarcates the sarcomere. Very important distinction to make. So between this Z line and this Z line, this is the sarcomere. And we have repeating units of these sarcomeres throughout the length of the myofibril, okay? So I'll go over that one more time, and then we'll look at it probably next time. So we have in the middle the M line that is connecting all of the myosin or thick filaments. We have the H zone, which is just myosin filaments. We have the A band, which is the area of overlap, the only area of overlap, right, between actin and myosin, between thick and thin filament. Out to the periphery, we have the Z line. The Z line borders the sarcomere, okay? So from one Z line to another Z line is a single sarcomere. And then going down the middle, or on the areas around the Z line, rather, are the actin areas, the thin filament that, again, is much lighter staining because of the thinner filaments that are present there, okay? Okay, any questions so far? Okay, let's talk a little bit about these individual proteins, and then we'll review that structure probably next time. We'll start with reviewing that structure. So looking closely at and I'll point them out here, actin here in blue and myosin here in red look like, if we look at them even closer. The thin filament is formed by actin. Actin is the contractile protein that is formed by these monomers of G-actin. So these globular proteins form themselves up into this F-actin, which is a fibrous protein. G stands for globular, meaning that it's a singular rounded protein. F stands for fibrous, that it now becomes a filamentous strip or a strand, if you will. And so now we have this strand that wraps itself around another strand, okay? So two F-actin monomers link themselves up into this helical strand, winding around each other, and that's what gives us our actin strand, okay? Now, there are a few regulatory proteins that are present on the actin strand. This is very, very, very important. This is a very important part of understanding muscle contraction, understanding these regulatory proteins. The first one is tropomyosin, and this is a thread-like protein that runs around this helix, runs around this double-stranded actin protein. And tropomyosin is actually blocking these binding sites. So the black dots that we see here along each of these monomers and along the entire filament are the binding sites for myosin. And in its relaxed state, these binding sites are occupied or covered, and they're covered by this regulatory protein, tropomyosin. Okay, that's one. Troponin, which is our second regulatory protein, is a complex of three other attachment sites, three other proteins, okay? And so we can see this structure here, which is a complex consisting of three smaller protein subunits. That's troponin. There's an attachment to actin, to the blue structure, to the entire filamentous protein. There's an attachment to tropomyosin, to this thread-like regulatory protein, and there's an attachment to bind calcium reversibly, okay? This is a very important part of understanding muscle contraction, and this will come back again and again and again, so please make a note of this. We have troponin, that complex of three proteins that attaches or binds three different areas. One attaches to actin, which is the entire protein in blue. One attaches to tropomyosin, which is this thread-like regulatory protein. And then one is going to attach to calcium, okay? This is really where the magic of muscle contraction happens, right? Calcium binding to this troponin molecule is going to shift that tropomyosin off of these binding sites, and that is going to facilitate muscle contraction.